So, welcome to day 2 of probability. Today we are going to continue talking about two-way tables, but this time it's going to be based on probabilities. So if in a problem we are given something in terms of a percentage, what we might want to do is make sure that the total in our table adds up to 100%. So what we would call our grand total would actually be adding up to 100. If we're given probabilities in terms of decimals, I guess you could convert to percents if you'd like, or you can leave them in terms of decimals. And then our grand total box in the corner would have to add up to 1.0 or 1. So let's read our first example that's in terms of percents here. Suppose the following information is known about Rufus King High School. 40% of the students are involved in a sport. 58% of the school students are female, and it says the athletic director indicates that 65% of those involved in sports are male. So I'm hearing a couple different things: being involved in a sport, female, and male. So remember, you always need opposing categories when you're doing a two-way table. So maybe your first category maybe would be female, and its opposing category would be male. For the other two categories, let's have, plays sports, and then maybe no sports. All right, so let's reread those percents again. 40% of all students are involved in a sport. So if we know our total has to add up to 100%, 40% out of that 100 would play a sport. That probably leaves us with 60%. So let me change my color. That means 60% is going to not play a sport. All right, let's read the next one. It is known that 58% of the school's students are female. So this is going to say 58%. And so if 58% are female, then that means 42% must be male. All right, and then the last piece of information here says, additionally, the athletic director indicated that 65% of the students in sports are male. Please do not put a 65 in the box where male and sports come together. That would be more than the total percentage of sport players. What we need to do is find out what 65% of the 40 students that play a sport. So if 65% of the sporting people, so 65% of the 40 students, that tells me what percent are male. So 26% is a male sport player. All right, so now what we need to do is fill out the rest of this chart by just adding or subtracting to our marginal totals. So now that we know that males are 26, females are going to be 14. Because 14 plus 26 is 40. If we know females are 14 and our total female is 48, then that means 44 females don't play a sport. And then you can add across or down however you want to, but this box will be 16. All right, so now we have our entire table filled out, and we should be able to find each of the probabilities given below. So find each of the following and identify it as conditional marginal probabilities. And I'm actually going to add one more type in here. I'm going to call it joint probabilities. All right. Round to the nearest percent where necessary. Okay, the probability that a randomly selected student is male. Well, that's going to be a marginal probability because there are 42 total males out of the 100 students, and so that's going to be 42%. The probability that a randomly selected student does not participate in sports. So look at your no sports marginal total, and there are 60% of students out of the 100 that do not participate in sports. The probability that a randomly selected student is male given, okay, given is a huge indication that this is a conditional probability. So given they don't participate in sports, so only look in that row. Given they don't participate in sports, so there are 60 students that don't participate, what is the probability of picking a male out of those 60? So look in that row. This is our denominator. How many males fall in that row? 16 out of 60. So this is where, if you wanted to pull up your calculator and divide that out there, so 16 divided by 60, that's how I would determine my percent, multiplied by 100, and convert that into a percent. It says round to the nearest percent where necessary. So if this is going to be 0.26 repeating, that's going to be approximately 27%. The probability that a randomly selected student is female, and when you see the word and, that is a joint probability. That's where two categories come together. So female and sports. There are 14 females that play sports. So 14 out of the total 100 would give me a 14%. The probability that a randomly selected student participates in a sport, here it is again, given they're male. So look in the male column only, and in the male column there are 42 total males. That's my denominator. And out of those 42, how many participate in a sport? So out of the 42, it looks like 26 of them participate in a sport. So again, I would take out my calculator, I would divide those out. I won't show the calculation this time. You get 0.619 ... and it wants you to convert it to the nearest percent. So I'm going to say approximately 62%, and that was a conditional because it used the word given. All right, last one is not a type of probability. That's why in the directions it says except F. It says the probability of a randomly selected student is male or participates in sports. When it uses the word or, that brings up a different conversation. So first you want to find out how many males there are total. So let's think of that as 42 males, or 42% are males. Or they could participate in sports. So that's 40% was, remember, sports. So we have sports here and total males here. But if I'm adding up these 42 and these 40, then that means these 26 males that play sports are being counted twice, and I only want to count them once. So when you see or, you're going to add the two marginals, marginal plus marginal, and subtract the joint probability of those two, and that will give you your or. So 42 plus 40 minus 26 is going to give me 56. And then I want to turn that into a percent, so obviously 56 out of the total 100, and I could have probably just put a percent sign on it, but just so in case. All right, so that's how you would do or. So that's when everything is given to you in terms of percents. But now let's do an example where we have to come up with our own two-way table and everything's given in terms of probabilities. So our total is going to be out of 1. When a fish is randomly selected from a tank, the probability it has a green tail is 0.64, and the probability it has red fins is 0.25. The probability it has both a green tail and red fins is 0.19. Construct a two-way table representing this data, and keep in mind all the numbers must add to 1.0. All right, so if we are constructing our two-way table, remember we need opposing categories. And when I read this, I'm reading green tail versus red fins. So I need green tail, so I'm going to call this green, and maybe not green. Those are opposing categories to each other. The opposite of red fins would be not red. Okay, the safest way to make a two-way table is to do something and then the opposite one be not that something. All right, so here are our two-way categories. And we know that the grand total has to add up to 1.0. All right, so let's reread and let's fill in what we know. The fish in a tank, blah, 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 the probability it has a green tail is 0.64. So there it is, 0.64. And if you want to do the same thing we did last time, If we know our total has to add up to 1.0, and that is 0.64, then that means the probability that it's not green, I probably should use green, that would be fun. The probability that it's not green is 0.36. All right. Read the next sentence. The probability is red fins is 0.25. So if that category is 0.25, then not red would be 0.75. And then the third and final piece of information they give me is that it has a green tail and. Remember, that is what we considered a joint probability. So it's where green and red come together, and that's 0.19. And by a little math magic, you can fill in the rest of this chart by subtracting from the marginal totals here. I'm going to continue using my blue color here. So 0.25 minus 0.19 is 0.06. 0.64 minus 0.19 would give me 0.45. And you have probably 4 different ways you can figure out this missing box. And that's going to be the not nots, the not reds and the not greens, and so that's going to be your 0.3. So now using our two-way table that we just created, let's answer the problems below. What is the probability that a randomly selected fish has a red fin and a green tail? That was actually given in the problem. Now what's nice about a two-way table that's in terms of probabilities is actually the number that's in your table, the 0.19, is your answer because it asks for the probability, not the percent. If you wanted to convert to a percent, you just have to multiply by 100 and it would be 19%. But this is just asking for probability, so I'm done. So this was a joint probability. What is the probability that a randomly selected fish does not have a green tail, or sorry, does not have a red fin or a green tail? So let's find that. So what is the probability that a randomly selected fish does not have a red fin or have a green tail? Well, if it doesn't have a red fin or have a green tail, that's going to fall in the not category. So that is just going to be 0.30. Another way you could interpret this question, however, would be what is the probability that it does not have a red fin and not have a green tail? So that's just another way to think about it. Just the way that it's worded, the fish does not have a red fin or have a green tail. So it's a not is really what that's asking, and that's another joint probability. What is the probability that a fish has a red fin? There's our secret word, given, so that's conditional. So given it has a green tail, in my two-way table, 0.64 will be our denominator because that is the marginal probability for a green tail. So given it has a green tail, what's the probability it has red fins? So that would be 0.19 out of 0.64. And then you would take out your calculator, and it does not provide rounding directions. So you are going to write down every single decimal that your calculator gives you. One thing about probability is if it said exact, you would actually leave it as a fraction. This one doesn't say exact, so we can actually make it a decimal, we just won't round it. So we're going to do something similar in letter D. What is the probability that a fish does not have a green tail given it has a red fin? So go up to your two-way table, find out your red. Your red total is 0.25. Out of those 0.25, what's the probability it is not green? So out of this category here, the probability it's not green is 0.06. So 0.06. Divide those two out, and actually it's not too bad of a number, 0.24. So kind of nice. Oh, no, I don't like that answer. That is not the answer. Oh no, actually it is. If only I knew how to edit this video. Yep, nope, that's all good. All right. What is the probability that a fish does not have a red fin given, there it is again, given it does not have a green tail? So given no green, there's our denominator. This is conditional, this was conditional. Given it does not have a green tail, what is the probability that a fish does not have a red fin? So let's go back up here. Not green, not red. So that's 0.30 out of 0.36. Divide those two out. I get 0.83 with the 3 repeating. And that's your probability. Remember, these did not say find the percent. Lastly, what is the probability that a randomly selected fish has a red fin and doesn't have a green tail? So and is a joint probability. That's where two categories come together. So red but not green. So red but not green. Red but not green is 0.06. And that's actually our answer. We don't have to divide by anything because if anything, you would have divided by the grand total, and anything divided by 1 is itself. So you would have gotten the same answer back. All right, that takes us to the end of day 2.